boa tarde a todos. Em nome da Efígie, eu gostaria de agradecer a participação de vocês no evento de hoje. Estamos dando início a mais uma mock class. Atualmente estamos tendo aulas da trilha de Engenharia, Tecnologia e Inovação. Lembrando que ao todo são 4 trilhas de temas variados que vocês podem ter contato com universidades e pesquisadores de diferentes universidades do mundo inteiro. Então, essa é uma oportunidade muito legal para vocês também verem, saberem como é uma aula de graduação, de pós-graduação, com professores que têm doutorado e pós-doutorado. E um outro recadinho que eu gostaria de dar para todo mundo é que no final de cada trilha, a gente vai ter um sorteio com vários prêmios para os alunos que tiverem participado de mais trilhas. Então, fiquem sempre ligados juntos nos canais com a gente. A gente tem nossos canais nas redes sociais, né? Tanto uma página no Instagram e no Facebook. Então, gostaria de convidar todo mundo para curtir e seguir essas páginas. E, além disso, a gente também tem um canal do YouTube, que é atualizado constantemente, com informações muito interessantes para vocês, e um grupo no Telegram, para vocês ficarem ligados de notícias sobre bolsas, aulas e outros eventos gratuitos, como as mock classes, que vai ter ao longo do ano inteiro. A gente também vai ter a University Global Week em maio, que vão ser dias de cada região do mundo, em que vocês vão poder conhecer universidades diferentes, então, da Austrália, da Europa, da Inglaterra, dos Estados Unidos e do Canadá. Então, quem quiser participar do grupo do Telegram, pode deixar aí uma mensagem que a gente vai adicionar o número de vocês. E também para ficar por dentro dos programas da Efígie. Então, hoje a aula vai ser sobre reciclagem de água doméstica, que é um tópico assim, bastante interessante, relevante na área da sustentabilidade. E, como eu falei, com a mock class vocês têm a chance de ter uma aula de uma universidade estrangeira sempre muito bem renomada. Então, hoje é com a SRA de Heidelberg, com a professora Ulrich. A professora Ulrich, ela é engenheira de processos, também tem doutorado na área de reciclagem, e essa é uma universidade da Alemanha com milhares de alunos, muito conhecida. Então, ela vai explicar sobre como que funciona o processo de separação e reciclagem da água doméstica. E eu só vou introduzir agora a professora Ulrich e ela já vai começar a aula. So, please welcome Professor Ulrich.
Welcome everybody, and thanks first of all for inviting me to giving here the class regarding wastewater recycling. I also want to just shortly introduce myself, as well as I guess Enrico just did it in Portuguese. So I'm from the SRH University in Heidelberg. I'm a professor for environmental and process engineering. And at the SRH Heidelberg, I'm leading the master program of water technology. And that is the main reason why we talk today about water. So let me share my screen. I hope you can see the first slide, and then we can directly start with our topic of today about domestic wastewater recycling. But first of all, I want to start with the water as one of our global challenges in the days of now. The United Nations defined the access to drinking water as a human right, but still billions have a shortage of it. Furthermore, half of the world's population faces the risk of water shortage. The global water demand is increasing and increasing. Furthermore, the amount of clean drinking water in many regions is decreasing because of its pollution. And due to our climate change, we have floodings and aridities, which identify also the challenges of the water supply. When you talk about energy, also the energy production requires water, and of course, clean water requires energy as well. And the topic what we're talking today is about safe sanitation. More than 4.3 billion of people cannot use safe sanitation. And there are a lot of new alternative sanitation systems. And when we talk about domestic wastewater recycling, that is one of our directions of these new alternative sanitation systems. So after our lecture, you know more about alternative sanitation systems, its objectives, and also the main advantages for our future when talking about water as global challenge. Everybody knows that we have a lot of water on the earth, so the water is always there, and more than 70% of the Earth's surface is covered with water, but you know, most of this water is the salt water in oceans, and just a small amount is our fresh water. When you have a look here at this diagram, and you see here the salt water, about 97% of our Earth's water, you see that only 3% is fresh water. Out of these 3%, a lot of the water is in the ice caps and glaciers, so you cannot really use them. And a small part of that is our surface water in the lakes, rivers, which we really can use. So about 1% of the water on the earth is really fresh water, which we can directly use as drinking water.
The most part of fresh water is frozen, right?
Yes, the most part you see here, 69% is in the ice caps. Yes, so the most part is frozen.
Unfortunately,
you have a lot of that water. Then when we talk about the resources, it's quite similar about the surface water, river, lake, sea, the groundwater. Now we're coming also to the rainwater, air humidity, and the leachate. And when you check this picture here, you see all the different pathways of pollutions, how it gets into the water. We have landfills, we have polluted air, we have industries, and so on. All that is getting into our water, and we need the wastewater treatment. So also when you have here the houses, we have our domestic wastewater, and that is the part which we are going to talk about today. Also, this has an influence on the water quality. You have the wastewater treatment for it, you have the drinking water treatment, the climate, sediments, all that are influences on the water quality. And the main part we're dealing with is the wastewater treatment. To get into the topic, let's start with the domestic wastewater recycling now. This is one big part of sustainable water resource management. And so here's, as you all are living somewhere in your household, you might directly think about drawing a house, for example, and think about the different wastewater streams which are occurring in your house. So what do you think? What do you have as different streams in your house? What do you have as wastewater when you have a look at your house or your apartment?
Teacher, can you repeat the question?
So it's which wastewater treatments occur in your households. So you might think about the different rooms you have, and in which of those do you have wastewater?
So you have from bathrooms, I think.
Yes.
And cooking.
Yes.
Maybe it's from rainwater.
Yes, you can take that as well.
The water from the doing the dishes.
Yes.
washing the teeth?
From the filter?
Yes. So when we just go through the rooms, you mentioned a lot of you something from the kitchen. So you have here, you have washing the dishes, but also some leftovers from your cooking is getting into the wastewater. You're having the rainwater. You're having your bathroom from the shower, from the bath. You have your restrooms with the toilet. There, of course, you have a lot of wastewater. And then you have, of course, other topics as, for example, washing machines and so on. When you have a look at these streams in general, we classify these streams of domestic wastewater in black and gray water. Does anybody of you had heard these wording of black water and gray water?
So I imagine that black water may be related to bathroom water.
Yes, so somehow, so we have the black water, that is that water which is from the toilet. So it's really just the your toilet wastewater, but of course including papers used and the flushing water. And the gray water is all other water which is in the house despite of this black water. When you have a look here at this graph, you have here the domestic wastewater is separated in the gray water and the black water. You can furthermore have a look at the black water. I've used here also the colors. When you have a look at the black water, you have the main part in volume is the flushing water. And then you can further divide the black water in yellow water and brown water. These are really, let's say, terms which you use in scientific way for classifying the domestic wastewater. I guess it's clear when you talk about the yellow water, that is our urine, and the brown water is our feces. You see here also the amount. So of course, the flushing water is the most of the water you use. And then you have a bit of yellow water and brown water. But why do we have classified these waters into black and gray water in a household? So think about the questions, what are the characteristics of the individual domestic wastewater streams? So when you think about the gray water, which is coming from bathrooms, from the shower, from the kitchen, and in comparison, your black water, what is coming into your mind? What could be characteristics of the two different streams here?
So I believe it might be physical characteristics, differentiation,
yes.
And color, perhaps.
Yes.
And is pressure of like thickness of the water.
Yes. So let's go a bit more detailed into that. We have just had here the classification. So the main part you see here is when you talk about the amount in volume, gray waters around 60% of the domestic wastewater, and the other 30 to 40 is the black water.
Teacher,
the flushing water has the most part. Yes, you had a question?
can you say black water some examples of black water, gray
Black
water.
water is the toilet wastewater.
Oh, and gray water.
And gray water is all other water which is wastewater in your households, as kitchen wastewater, wastewater from your shower, wastewater from your washing machines, all others wastewaters without the toilet wastewater.
All the ways we can waste water, right?
Yeah. Yes.
And in our home.
Yeah.
Thank you very much.
So we have here the black water, the gray water, but let's go a bit more into its characteristics. So when you talk about pollution of the wastewater, you always have the organic load as a main criteria. That what is really polluting our wastewater. It's a lot of loading which is included there, but you have one big parameter which is just called the organic load, which needs to be degraded in a wastewater treatment plant. When you say your organic load of the domestic wastewater is 100%, as it's shown here in the graph, you see that around 40% of that load is from the gray water and about 60% is in the black water. But when you want to when you want to have a look at these 60% in detail, you see that more than 50% of the organic load is in our brown water. When you just remember the graph before, in the kind of volume, the volume of the brown water is negligible. So when you think about all the water which is as wastewater in your houses, the feces, it's really in amount of volume, nothing, but the organic load is very high. Furthermore, all the toxic substances are in this brown water. So one main reason why you separate the gray water and the black water is the pollution of the yellow water and the brown water. I want to show this here once again with two substances which are nitrogen and phosphorus. Nitrogen and phosphorus you use in agriculture for fertilizing, but if you have too much of this nitrogen and phosphorus, you have a lot of negative impacts in agriculture, but as well in lakes and rivers. When you have here on the y-axis, once again, the 100% of load of nitrogen, you see that the gray water is around 10%, and the black water contains around 90% of the nitrogen. And here, a lot of that is in the yellow water. The same or quite similar is for the phosphorus. Here also, a lot of the phosphorus is in this yellow water. As I said before, nitrogen and phosphorus can also be used as fertilizers. So one idea about this source separation in domestic wastewater recycling is also to recycle these nitrogen and phosphorus out of your black water to have it for certain other purposes later on, as for example, as fertilizer. So here that is mainly the one of the big issues, that you have a quite clean gray water and a very polluted black water. When we summarize these aspects, we can say that the gray water has a higher volume than black water. That the organic yes?
Isn't false? Gray water has a higher volume than black water.
That when you have a look at your house, and the gray water is all the wastewater.
Oh.
Okay.
Oh, okay. Sorry.
And the organic pollution in gray water is significantly lower than in black water. So here you can really say gray water is the clean wastewater in comparison to the black water. Here also the nutrients as nitrogen and phosphorus are mainly contained in the black water. So when you have a look here, not separated in yellow and brown water, just the black and the gray water, here you see really the amount of nitrogen and phosphorus and that of the gray water. So you see here the main reason for this domestic wastewater recycling, which is also called source separation. When we have now talked about the question of which wastewater streams occur in households, as well as the characteristic of these individual domestic wastewater streams, we need to talk now about the treatments which would be useful for a decentralized wastewater treatment. Do you have any ideas what would you, when you now know that your gray water is not that polluted, your black water is highly polluted, maybe also with the urine, the feces as yellow and brown water. Do you have any ideas or solutions with what you would say which can be used for a decentralized wastewater treatment?
Maybe boiling the water?
Yes, but when you boil water, of course, you have clean water, but normally boiling, you need a lot of energy for boiling.
Okay.
So that is main.
You can use filters, perhaps.
Yes, that is the first step for the wastewater treatment.
Teacher, we can use sand, stone, and other things to have a treatment of the water, right?
Yes, yes. Okay. This is a good. That is also one of filtration treatment, what your colleague has just mentioned before. So these sand filtration is often used for the gray water because you don't have any harmful substances. When you do the sand filtration with the black water, you have a lot of odor. When you think of your toilet wastewater and you just give it into the sand, you still have the odor, you still have the toxic substances from, for example, your pharmaceutical residues, etc., what is all in the black water. For the gray water, this is a very good treatment, and it's also used, and that is why you do this source separation, because you can use cheaper technologies for the gray water and treatment and then recycling.
Teacher,
other ideas?
What's the healthy water?
Sorry, once again, please.
The healthy water.
Yes.
What's the healthy water?
I think he's asking if the water that is recycled from black water could be usable or suitable for drinking, for instance.
So there you need to know, normally you can treat each and every wastewater to drinking water purposes. That is possible for each treatment, and the challenge are just the cost. And then the behavior of the people, if you would really drink the clean water when you know that it was in the toilet just before. So that is more about the behavior of the people, but it's not a challenge for the technology, but for the costs. And when you talk about decentralized wastewater treatment, which is for the households, it would be too expensive. That can be more used for the gray water treatment. Let's have a look at some examples, then you can more understand about these streams. Here it's one called loop process, that is black water recycling process. Here you have one box with the toilet. First, you have the solids removal, which one of you said you need a filtration. Of course, you have a lot of solids. These solids often can easily used in a biogas plant. There you have solids. You also have chicken dung and so on. So here also these solids from the brown water can get into the biogas plant. You have a collecting tank, and then you have a bioreactor. A bioreactor is useful for all the wastewater treatment plants. You have a biological process, and these species which are living there, the microbiological reaction, they degrade all the organic load that the water is clean afterwards. Still, you need to have a filtration. Often it's ultrafiltration, as when you have the bacteria which are cleaning your water, you still you never want to have them in your water, so you need to have a filtration that they stay in your reactor. Here, the black water recycling process has the objective of using your water once again for flushing. So you have a closed loop. That's why it's also called loop process. You have just left out of your brown water for the solids, and then you reuse the water. After the ultrafiltration, your water is already clean. But when you flush the toilet with yellow water, normally the people don't want to use that, because when you have a colorful water, you think directly on wastewater, even if the chemical parameters show that it's clean water. So you have here decolorization step. That is one process where you save a lot of water, because you use a lot of water for flushing the toilet, as we have seen in one of the first graphs. Other ideas are also vacuum toilets, which can be used. Then you don't need a lot of flushing water, so you save the water before using such a recycling process. I come to one example later, which is with the vacuum toilet in combination with gray water recycling processes. Here we have a list of gray water processes. You have here this sand filtration, which one of you has mentioned. This is possible. You have a constructed wetland. These are plants as reed, for example, which is cleaning your water. And then you have all the high technology processes which are used in normal wastewater treatment plants or industrial wastewater plant. You have all these are biological treatment processes with just different technologies. Optional, you have a treatment for the disinfection, which can be done by UV or ozone treatment. And then you have different applications, and depending on the application, you need to check if you need to use optional treatments. If you have potable urban uses, of course, you need a disinfection. When you use it for landscape irrigation or agricultural irrigation, you don't need to have a disinfection. So for the gray water, the two processes here at the top, the sand filter and the constructed wetland, are very, in comparison to the technologies below, very cheap processes, but they are completely efficient for the gray water, as it's not that polluted. So when we normally do this lecture, I just wanted to show this review of my lecture of environmental engineering. Here we draw the houses with the different streams, which we have talked about at the beginning. We also have the bottles of different wastewater streams to just have also a visual aspect of it. And then we create scenarios how to treat that. So we don't have that much time. That's why I just present some possibilities to do these scenarios. And I want now to come to, really application examples which are used here in Germany, which we have visited. One example is a student resident. It's called Eastside, which is in Mannheim, which is a big city near Heidelberg. And here we have a gray water recycling process. We have filtration, a biological treatment, and an ultrafiltration. And this water is reused for toilet flushing. So with the black water Lulu process, which I have shown you, this can also be used for the gray water. Here you can also reuse this gray water with a quite easy treatment to reuse it for flushing. Here you have just a photo for the impression how these student residents look like. And in the cellar, you have the tank for the gray water, your treatment, and then you have your clean water, which is used for toilet flushing. Normally 44 liters per day are used for flushing the toilet for one person in a day. Around about 200 liters are the whole water consumption. So you save a lot when you have recycled water for toilet flushing. Another application example is a whole area. This is a whole residential area in Germany, and it's a quite ecological village with different aspects which we have talked about. Here we have a vacuum toilet. So we don't have the flushing water. A vacuum toilet, you might know from trains or from planes, there you always have also the vacuum toilets. Then you only have the black water. So the volume is not that high. And with this black water, you go in a biogas plant, as also in one of these examples before. When you have the biogas plant, you gain biogas, and with that you have heat and electricity. So this village gets its heat and electricity out of this black water. In addition, you have here the kitchen waste, the bio waste. You also give that in the biogas plant. Furthermore, you have a storage for the digestate, which you can give into the agriculture for fertilizing aspects. Then our other water, when we talk about source separation, we have our gray water. Here it's showing once again, shower, bathroom, washing, that are the main aspects from the washing room and also from the kitchen. Here we have a reed bed filter, so a constructed wetland. So this wastewater don't get into a wastewater treatment plant. It just get into such a constructed wetland, and then you have the water which is getting, for example, with the stormwater for the infiltration. And they have also a small lake there. So the whole residential area does not need to have or give their water to a wastewater treatment plant. All that water stays in that ecological village, and you even get heat and electricity out of that. And this only is possible because you have the source separation. When you have here a mix of black and gray water, you cannot give it into the constructed wetland, then the plants are not able to clean it to our purposes. But our grain water, which is not that polluted, it's completely possible, as the substances as nitrogen and phosphorus are much lower. So this is our main example how you really can use it for a whole village. Here it's just for you that you, as I talked about the constructed wetlands, but what is really a constructed wetland for gray water? You have here plants. So here you see, I put also here some pictures from a constructed wetland, which I have worked with, you have different plants which are cleaning your water. You have here the inlet. You also, of course, need some air for the treatment. So that's why you have an air pipe as well. And then you have the water, and afterwards you have the clean water. Of course, you also need to do water quality tests. But as your gray water is not that polluted, such a simple technology is sufficient to clean the gray water. When we talk about this domestic wastewater recycling, I also want to go shortly to another topic, which is often combined with this aspect now in the research. This is the future of roof greening in cities. So you know that the climate change has a big impact also to the cities because they're heating up in the summer. But trees or green is cleaning that due to their evaporation effect. So possibilities are that you collect and store the rainwater for using for toilet flushing or in washing machines, so you save water. Others are that you clean the gray water on the roof surfaces of houses or also car parks in constructed wetlands or also in biofilters. So this is possible. Or you can also use your purified gray water for irrigation. For example, when you have really intensive roof areas, or also when you have big cities where you have hot summers, you can use it for evaporation in water retention boxes. So with these domestic wastewater recycling, you have also in the field of blue-green city approaches for cities, you can use this as aspect for just for domestic wastewater recycling as well. Here it's one example of a constructed wetland also on the rooftop, as it might be possible here on the picture. It's used for cleaning process water, so not the domestic wastewater, but also process water. It's on the rooftop of a company also in Mannheim of John Deere. So they're using to recycling their process water, which is also not that polluted. One aspect for roof greening, I just want to show you this new area. It's called Goethe Quartier. This is in Offenbach, and this is a pioneering concept of rainwater management. They use all the rainwater which is coming. They store it. They don't. So they have with these roof greening. They also fight against flooding if they come in rainy seasons or so on. Which also we're having also some floods of our river here in Germany. So this is just one example, which is not directly linked to the domestic wastewater recycling, but as we had at the beginning, talked about rainwater as one source in domestic wastewater. We can also use this for greening up the villages or cities. That was my last example. So thank you for your attention, and just let me know any questions you have.
So thanks, Professor Ulrich. It was really interesting. And I have a couple of questions. We are also streaming at YouTube. So I have my personal questions and some that was wrote on YouTube. And you students also can open your microphones in video to ask anything you want. So during your talk, I remember that a video that I saw with Bill Gates. They started with Blackwater, actually, and it's a filter in an initiative that Bill Gates was like investing. And at the end, he drinks the water that was derived from the Blackwater.
Yes.
So I would like to ask if you see this video and what sorts of filtration.
So I know that video, and when I walk more in the field of domestic wastewater recycling while I have done my PhD, my old professor, he's also doing all the same, because we had such a Lulu process with cleaning the black water, and there to showing the people that it's clean water, the best is to drink it. So that's why he also do that. For the treatment, you need a filtration, you need a biological treatment. Most important is that you have a disinfection step at the end as well. So when you don't have a disinfection, you also have it in your water supply system. So you need that as well. You would never die if you just take a dip, but if you really use it, always you need to have the disinfection. That's what I meant when you can clean everything. It's just the cost.
Okay. And also we have this concern with coronavirus on the black water and other kind of microorganisms. But I think you have said that usually by UV or ozone, right? That you make the disinfection.
Yes. Yes, there are a lot of researchers right now regarding the COVID in the wastewater, so that you know about the hotspots due to the wastewater, because even in your feces you also show the virus even if you're not sick and you don't have any systems for that.
I'm really happy that people submitted those questions, because those were actually 2 questions that I had in mind. Same questions. I think we all maybe had them.
So I also think it's very interesting, the thing with the rooftops. And I don't know, I know it's domestic, but I did not understood if it's a thing that the own company does or is related to the government, or it's a thing that happens in-house.
Yeah, so that's more depending. When you have it as this really big areas, normally it's from the city, right? But of course you can also do that on your own rooftop. So in Germany we have regulations for everything. So if you want to do something at your garden in your house, you need to ask the government as well, even if it's owned by your own. And you need to be sure. That's why you can only do that with gray water, that you don't have a smell, right? When you would use black water, it would smell, and your neighbors would hate you.
Nice. So you have a question from Isabel. Isabel, I would like to invite you to open your video and microphone so you can ask the question, but I can read if you don't want. Just tell me in the, okay.
I see it in the chat. It's a really, really great question. Really good.
So she said, I read a lot of articles that were about the possible of ends of humanity due to lack of water in 50 years, since we probably wouldn't have enough water for the entire population. Could that be reverted, solved, or delayed with the domestic wastewater recycling and other gray water and black water treatments?
So the main advantage is that these technologies can also be used in areas where you don't have a lot of money. So normally, we have a lot of water in the world. When you have a quite rich country at the sea, you can use desalination technologies, and you always have drinking water. But for this, you need a lot of energy and you need a lot of cost. So normally people don't have the money really to do that. And so there you need to search for cheaper solutions which can be used worldwide. And this is one topic which just save water. And when you save water just with reducing the flushing water, you can use this drinking water for other purposes.
Right, thank you. So I think Guilherme Vitoriano also asked some couple of questions in the chat. So Guilherme, if you want to open your microphone.
Hello.
Hi.
I don't have any questions anymore.
So he already asked it during the presentation. So
what I have just heard, what Steffi and me talked about at the beginning, we have two events in Germany which are dealing with these purposes. So where I would like to invite you as students, as nowadays a lot is online, you can also attend these two events. I just go on with this slide. So we have the World Water Day on March 22nd. And there we have our online digital conference with international water experts. There we also have topics regarding the COVID pandemic and the comparison with wastewater, for example. Furthermore, we want to have an online poster exhibition. And so I also want invite you to submit your poster, and we award also the posters. We have created a world map on the Padlet. I guess Steffi will also send the link into the chat. So here I invite you to upload your poster, and that we will create a great world map. The winner poster is also wins a participation at our summer school. I would also highlight the summer school. This is financed by the German exchange office. So you also, we have quite a good event. We did it last year. So watch also our videos on YouTube to have a look at that. So here you have the link to our World Water Day. Everybody is invited to participate. And then we have each year now our summer school Mecca Now, which is our international summer school with approaches this year towards resilient cities. So this is combined with the topic of roof greening, for example, stormwater, and so on. So I invite you, so those are interested to learn more about the resource water, just join our events in the coming month.
Dr. Guy, I noticed Alessandro had their hand up. Alessandro, did you have a question or?
Yeah.
Yeah, please.
Yes.
So earlier you talked about purified gray water being used in irrigation. And so I wonder, is it safe for drinking?
No. So you can use it for irrigation, but it's not. So when you have a disinfection, then you can use it for drinking water purposes. But when you just use it for irrigation with the EPA treatment, you still have pollutants that it's not drinkable.
Okay. Does it still have solids or no?
Sorry, a challenge to clean it, or
solids? Does it have like organic matter, or is
yes,
it just
they have organic matter. In the black water is much more organic matter than in the gray water, but still gray water is a wastewater. So still there's organic load. So just from your shampoo, you have the organics in the water.
Okay, so thank you.
That harmful, it's not drinking water.
Okay, thanks.
So if there anyone who wants to ask another question, we are still open. No.
If you want, I can show them the Padlet since we have a few minutes left.
Okay, Stephanie.
Because I thought this was really cool. I don't know if Dr. Guy had seen it yet. I don't think I got a chance to say hi at the beginning, but I'm Stephanie and I work in the international office at the university, and I work together with Efígie as their main contact at the university. So you're in really good hands with them, and if you have questions, they can always come to me and I'll get them connected with everybody at the university. But may I ask for the host rights so that I can share my screen for the Padlet?
I can also open it,
yeah,
Stephanie.
I think Stephanie has to stop sharing. then you will be
You see
able.
my,
Sorry, I think now you can, Stephanie.
I just did it. I think, can you
There we
see the
go.
world map?
Yes.
So I thought this was really cool because you can see the people who are going to be going to the event. They're from literally all around the world, and they're bringing their input and ideas into this. I'm the one over in California in the US because that's where I'm from. But you even have colleagues and experts. They're all joining this.
Yeah. So just you can just add a new point and just upload any topic to, yeah, which is relevant water to me. So what does water mean to you? Why is it important? Any solution or just anything what you like to. So one colleague from Ecuador, she took part at our summer school last year. She showed here is a timeless treasure. So you're welcome to upload any ideas and be part of our online poster gallery.
I think that Maria Clara is trying to make a question. I've seen someone open the microphone.
I just muted the microphone because I am.
So,
and I don't want to bother you.
anyone?
I think somebody maybe has their microphone on by mistake. If not, if we're wrong, just write in the chat because obviously it wasn't properly. Sorry.
I hear someone saying hi.
Yeah, me too. If you want to write in the message, it works as well. Or if you want to open the microphone. Right. So I would like to thank everyone from being here. Thank you, Professor Rurik, Stephanie, and also all the students that have participated. You can have your certification from the Simpla website. So you also can be in contact with us and SRA as well. And thank you so much, guys.
Thank you so much, everyone, for hosting us, and thank you, Dr. Guy, for joining. I learned everything new today. This was really interesting for me also. So thank you so much.
Thanks a lot. You're welcome, and thanks for inviting me to do that lecture.
All right, so cheers, everyone. Drink your water and appreciate it.
Bye-bye, guys.
Bye.
Bye. Take care.
Bye.